In this activity, we will be verifying the properties of parallelograms. So the objective is to prove or verify the properties of parallelograms. Let's understand what are parallelograms and what are the various types of parallelograms. So when we talk about parallelograms, the word parallelogram includes parallel, that is something which do not intersect. So in a parallelogram, we will have opposite sides parallel. That means they will not be intersecting. Just like a square, if you draw a square, you will find that the opposite sides of a square, that is AB and CD, these two are parallel, and even the other pair AD and BC, that is also parallel. So that's a parallelogram. Likewise, we have a rectangle. A rectangle is also a parallelogram, and a rhombus is also a parallelogram. So we will be verifying the properties of a square with relation to the sides and the angles and the diagonals. So we'll be verifying that the sides, all the sides of a square are equal, and then the angles are all 90-degree, and the diagonals, the two diagonals AC and BD, they are equal and perpendicular to each other. Likewise, in a rectangle, the opposite sides are equal, all the angles are 90-degree each, and the diagonals are equal. In a rhombus, we have all the sides as equal, like this. All the four sides are going to be equal. The opposite angles are equal, and the diagonals are unequal. They are of different length, but they are perpendicular to each other. So these are the various properties of squares, rectangles, and rhombus which we are going to verify in this particular activity. The material required include sheet of plain paper, then pencil, set square, ruler, all the geometrical instruments, and we also require a non-elastic thread. Let's see how this activity is performed.
So to perform this activity on comparing the length of the diagonals of a quadrilateral, like if we have drawn a rectangle here, A, B, C, D, as you can see is a rectangle, and we want to compare the length of the diagonal BD and the diagonal AC. Then how do we do it? We just take a thread and keeping one end of the thread at A, exactly at the vertex A, we stretch it up to the opposite vertex C. So I've got it here because the length of the diagonal AC is up to this. So this free part of the thread actually represents the length of diagonal AC. To measure AC, you can take a scale and keep the free end at the 0 and check the length of the thread. So in my case, it is approximately 16.2 centimeters. So for your figure, it will be a different measure. So you can measure AC like that, and similarly, you place the free end at B and the other end at D. You will get the length of BD in the similar manner. These the two recordings have to be done in the table here, AC and BD. So for a rectangle, you will measure AC, you will write it here, the length, and then measure BD, write the length here, and you will see that the length of AC and BD in case of a rectangle are equal. So whether they are equal or not, you will be recording it in the table here. Likewise, the same thing can be done for a square. Now this is the cutout of a square. Now if you want to measure the diagonals, you can just place the free end at one corner and take the length up to the vertically opposite corner, and this will give you the length of the diagonal of that particular square. Likewise, measure the other square, keep on recording in the table the nature of figure, the length of AC and the length of BD, and then checking whether AC and BD are equal or not. You will find that in case of a rectangle and a square, the AC and BD, the two lengths will be equal, but in case of this a parallelogram and a rhombus, you are going to find that the length of the diagonals will not be equal to each other. And that completes our activity on comparing the length of the diagonals of various quadrilaterals.